from our on behalf of our institute, I would like to welcome all the attendees and our speaker, Professor Jozef Haponiuk, to this episode of the webinar series 2020 conducted by JIS Institute of Advanced Studies and Research, Kolkata. So the situation, as I said, that is still not normal in some places here in West Bengal, India, as we are getting the news around the places. So on behalf of JIS IASR family, I sincerely pray for the safety and prompt recovery of all those cyclone affected people and their families. So now I am immensely happy to invite and to welcome our today's guest, Professor.
Hello, I have lost your voice.
Yeah, I got disconnected. Hello, Dr. Shubhankar, can you continue?
Yeah. Now it's okay.
Okay. Just briefly, I would like to give a short introduction for Professor Jozef G. Haponiuk, and who born in 1950 and obtained his PhD a long time back, 1980, from Technische Hochschule Leuna, Meeresberg Institute from Germany, and where he studied around 7 years. He did his master, MSc and PhD, and followed by he is now employed at the Gdansk University of Technology. In short, it is GUT, since 1974, and from 2006 he is the head of the Department of Polymer Technology at the Chemical faculty of GUT, and his department's special scientific interest includes the chemistry and technology of polyurethane elastomers and foams. At the same time, they also work on use of renewable raw materials, including chemically modified vegetable oils, starch, filters of natural origins, fillers of natural origin in polymer technology, and also they work on chemical recycling of polyurethane elastomers and foams, rubber processing and recycling and use of renewable raw materials in polymer technology, polymer nanocomposite, new varieties of technical polyurethanes, biomedical polyurethanes, biopolyurethane, biopolymers, polymer blends and composite, and so many things. And what I would like to mention about Professor Haponiuk, that he is author or co-author of over 300 original scientific papers, including 102 published in journals from the Philadelphia list. He is also the creator of 10 patents and 25 patent applications. And Professor Haponiuk is a highly regarded academic teacher. He was a supervisor for 11 completed doctoral students, and as well as he was also co-guided with Professor Shabu Thomas from Mahatma Gandhi University for four doctoral students. And so I don't like to extend this introduction more. So now I would like to request Professor Haponiuk, please, it is all over to you. Please, you can continue your talk at the moment. Your talk, today Professor Haponiuk is going to present his talk on rubber recycling by thermo-mechanical degradation. And welcome, Professor Haponiuk.
Thank you for the invitation to Kolkata webinar series. I'm very happy about it. Warm greetings to my friends from all over the world who are attending this seminar, and I will present our experiences about rubber recycling. Our department started working with rubber just after the Second World War, so it's over 80 years experience with different aspects of rubber technology. Nowadays, especially important is recycling of waste rubber, especially of waste tires, because they make the most amount of rubber wastes, about 80%. There are other elastomers based on, on rubber, like tubes, conveyor belts, wires, seals, and hoses. But as I have said, the most important thing is to deal with waste rubber from used car tires. Seat problems became very popular in the last 20 years. If we observe the number of articles containing the term rubber recycling in last 20 years, we can see about 2,000. There were not too many, but nowadays there are hundreds dealing with this problem. The same applies for citations to articles containing the term rubber recycling published in last years. Our department is publishing lots of articles on rubber recycling. I think we are in the first 5 universities dealing with this scientific problem. Compact car at present contains around 60 kilograms of rubber, and most of them, about 70%, is given by car tires. It means that all over the world we have about 17 million of used car tires every year. And in European countries, nowadays it is more than 3 million tons of tires. But as you can see, in Europe, almost all of used car tires are collected and utilized. It is about 90%, so it's a good achievement. It is not allowed here to store used car tires together with other wastes. But the majority of it, it's low cost, low property material. So we are working on upcycling of waste rubber with the aim to produce new rubber compounds with properties which are almost the same as of fresh rubber compounds. The development of production technology in Poland give us the 5th place in European Union, but the main part at present is disintegrating, becoming a fraction of different size, and use them as particles or as additives for asphalt mixtures. Here is a view of a new plant producing disintegrated rubber. But in many countries all over the world, and although in some places in our country, there are not legally dumped or stockpiled waste tires, which are dangerous as a habitat of insects, rodents, and risk of fire. So this kind of fire happens every year in different countries. Here we can see fire in Spain, near Madrid, 4 years ago, and last year we had 3 cases of big fire of used tires in Poland, which were placed legally, but there happened fires which were not expected and maybe not legally conducted. There is a problem with recycling of rubber, as with other polymer products which are cross-linked. So, and it is not possible simply to wash them and put into raw material stream as thermoplastic materials. This is very well known to everybody, and therefore there are many works, many attempts to elaborate a technology to devulcanize rubbers. It means to break cross-linking, mainly sulfur cross-linking. And it's a very difficult problem because the binding energy of sulfur is not very far from binding energy between carbon atoms. And the main thing is to make it in such a way that the main chain of elastomer, carbon-carbon bonding, will be not change. There are many waste rubber recycling methods. These mechanical, which include grinding, wet or cryogenic, are popular. We obtained crumbs for using as fillers, but the physical processes based of splitting chemical bonding is still a subject of investigation. So it is based on supplying energy like mechanochemical, microwave, or ultrasound to break the crosslinks. Sometimes also chemicals are added which help generally to avoid secondary cross-linking by reacting with radicals formed during physical processes. And the main directions like grinding and pyrolysis of waste tires and waste rubber from other sources is generally applied on industrial scale. The same is for reclaiming using pan processes and other processes with participation of chemicals. But it is very dangerous for the environment and producing a lot of wastes. So we are looking for green technology with very low pollution to the environment and allowing us to obtain rubber compounds of acceptable quality. The size reduction method is the most popular. It might be conducted at ambient temperature. It's more popular than cryogenic conditions because liquid nitrogen might be expansive in some places, but only at cryogenic conditions. A low size of particle is available, and both products show different surface which makes them to behave differently in rubber compounding. There are many stations that are popular. Here is one of them in our country, which could be put in small place, so in small community, which can then produce rubber in a form of ground tire rubber, GTR, which is then applied as artificial turf in playgrounds, low-cost filler in polymer composites, modifier of bitumens, modifier of concretes, and also as a product for pyrolysis or for reclaiming and devulcanization. Pyrolysis of waste tires and GTR is a rather positive way of utilization of waste rubber because of high energy content of waste rubber, and we obtain energy, still some volatile products which are used as fuel, liquid fraction used as substitute of diesel oil, and solid fraction pyrolytic carbon black. And this method is economical after so maybe of 3 to 5 years using of installation. And pyrolysis do not require cleaning of waste rubber and could be utilized to all kinds of waste rubber at once, because very often there is a problem of obtaining of good quality compounding if we take different rubbers as a mix of natural rubber and SBR, which are not compatible in rubber compounds. So the best method which bring us back good rubber properties could be seen in reclaiming or devulcanization. Generally, its transformation of waste rubber with different kinds of energy, transformation into a material which allow cross-linking, which allows us to manufacture new rubber compounds. How deep the destruction goes is connected with the method usage, and mainly with temperature, kind of chemicals, and the time of treatment. Obtaining of waste rubber of good quality just after performing a procedure of reclaiming is possible at using of thermo-mechanical reclaiming process. When we obtain reclaimed rubber, which can be transformed into new rubber compounds, again vulcanized to rubber products. And this process, we have we try to break different chemical bonds, and as we can see, the energy of sulfur bonds is the lowest, 270 kilojoule per mole, and the highest is the energy of carbon bonds. So applying shear forces, we put stress on the bonding, and we expect that the weakest bond, sulfur-sulfur, will break at the first moment. But as a result, we have destruction in the area of all bonds. It depends of activation energy and therefore on temperature, and the highest amount of broken sulfur-sulfur bonds we can expect at lower temperature and high shear forces, high shear stress. The reclaimed ground rubber is not a full linear polymer. There is still a certain amount of crosslinks, but we get back the possibility to revulcanize this product to obtain new cross-linked structure similar as at fresh rubber compounding. We worked in our team on this problem since maybe 10 years, and it started with a small project aiming at obtaining so-called butyl rubber, or compound behaving like a butyl rubber for sealing of windows. Somebody have seen this technology abroad in Japan and proposed us to develop a method, a process for obtaining reclaimed rubber with good properties, allowing us to use it as sealing tape for windows. Unfortunately, we didn't obtain the best properties and we couldn't introduce this product into the market. But we have learned a lot about reclamation, about rubber devulcanization, and since that time we try to go with development to obtain still better and better products and still better method, allowing us not to fully disintegrate waste rubber, but only in such amount that compounding will be still possible. And existing product is written leader in Polish language, but the meaning is the same like leader in English. It is development of low emission technology for production of modified reclaimed rubbers, but as an environmentally friendly method of recycling. It means using low temperature extrusion with the help of some plasticizers, with characterization of emitted volatile organic compounds, with the goal to obtain modified claimed rubbers with a possibility to process them and to show good property evaluation. The two main co-workers are Krzysztof Formela, excuse Krzysztof, and Łukasz Zedler. Krzysztof was my PhD student and Łukasz is at present my PhD student, but he will be ready at the end of this year. They have developed this method and improved characteristics of double screw extruder, furnished it with different additional apparatus, so they are able to obtain already products with really good quality. And we have here the extrusion conditions. So this extruder is working still on laboratory output 2.5 kilogram, but Dr. Forbera is cooperating with a bigger recycling company where a production line will be constructed very soon. You can see the screw speed is relatively high. It is 250, because at higher screw speed, of course, we have high shear forces, but the most interesting thing here is the low barrel temperature. It could be 60 centigrade or autotherm, it means the heating is only at the beginning of this process, and after that the heat generated by shear forces is big enough to be active at reclamation at devulcanization of this rubber. Because you can see that burn temperature in case of autotherm process is higher, but it is still low comparing to other methods because it is highest parameter is about 70 centigrade. At such low temperatures, there are not many volatile compounds, and they do not evaporate in big amounts as it was the case using temperatures of about 200 centigrades a few years before. It was really a problem. And the torque is similar in both cases. It is about 15 Newton meter. This reclaimed rubber is investigated for its properties without any additives or revulcanized using typical system for rubber containing zinc oxide, stearic acid, sulfur, and TBBS as sulfuric modifier. And we can see the appearance of GTR directly after this autothermal reclaiming, but it looks like powder, like steel crosslink product, but it isn't full cross-linked because it is possible to calendar this product and to obtain sheets of rubber compounding. And here we can compare the properties between different manufacturers and different producers. So our laboratory manufacturing is in the same scale as some other products. And we can compare it as raw product, GTR at 60 centigrade or autotherm, and after vulcanization with typical vulcanization system, tensile strength increases up to about 5 megapascal. We have elongation of break over 200, which is evidence of some degree of cross-linking. Hardness about 60 shore hardness A, and density typical for rubber. So the physical properties are not the highest as for rubber compounding and rubber vulcanizides, but they are acceptable for many applications. and condition of producing them are much more environmental friendly than of still used method working at higher temperature where the extent of breaking of chemical bonds is much higher, and when there are lots of volatile organic compounds. This process is observed for the temperature because we are aiming at low temperature, and the temperature is set and at the double screw extruder and measured at the output, and we see the difference at screw speed of 100 RPM and 500 RPM, and the temperature in the first case we have about 100 centigrade, and in the second case about 220. And on this example, we can see it is possible to obtain different reclamation products, different devulcanization degree, depending on screw speed at this process. That it is at higher screw speed, and the temperature is already higher, and we can see some fumes which we do not like. We are aiming at low content of organic volatile compounds. We can also measure the energy used for this process and observe all parameters. And here, this extruder is very convenient for research because we can open and see inside different stages of reclamation. So at the beginning we have a powder, and after that when the crosslinks are broken, we have a product which could be which could be formed using some stress pressure. So it's already moldable product. So we can try to see a short film. So you will observe the rubber, reclaimed rubber coming out of this double screw extruder, and after that the calendering of it, showing us that the reclamation was really done to this material. So you see, it could be pressed together, and in this form we can see it is possible to vulcanize it. So it's our technical laboratory. Still coronavirus. There are still fumes, but very little amount. If I could find the film from 10 years ago, it was a very bad process. How to go to the next? Ground tire rubber GTR after regeneration have still the similar thermal stability. It means there are not too many low molecular weight products inside this reclaimed rubber, because the loss of mass between different temperatures is similar for untreated and treated samples. So the current trends are the search for continuous devulcanization using extruders, and especially at low temperature reclaiming. There are not many industrial technologies. We do not know an example in Europe. We expect there are some in China, but they are not disclosed. And we do not know it is low temperature or higher temperature, and how is the environmental protection by some industrial used method. And this process could be supported by supplying of more energy in the form of ultrasound or microwave, and by some mechanochemical processes which are acting as plasticizers or as radical absorbers during this process. And for some active fillers, we can try to bring them another functionality to make them more compatible. And to introduce some groups which are not present in degraded rubber, like hydroxyl functionality for example, polyurethane foams, and also to use supramolecular interaction, which make it possible to process at lower temperatures due to breaking of this interaction at higher temperatures or by action of solvents. So there are some important advantages, like continuity, short time, high efficiency, and good quality. Problems at this devulcanization which is used is uncontrolled exothermic oxidation of ground tire rubber. So it shows us that the low temperature devulcanization might solve many problems used which occur at devulcanization at higher temperatures. It is an example of previous works showing characteristic of low temperature reclaiming, but 4-5 years ago we had still higher excessive thermo-mechanical degradation, which was improved at present at these products and these experiments which are performed nowadays. So comparing of properties showing us that at higher temperatures, the most important tensile strength and elongation and break abrasion resistance will be lowered, so the quality will be lower as well. And as already said, controlling of the atmosphere of volatile organic compounds is crucial for environmental friendly technology at low temperature devulcanization, and we are working on analyzing the atmosphere, which was not done before so exactly, putting some passive and probes directly above the apparatus, and so we can collect samples and analyze them by chromatography and to identify different low molecular compounds which are present in this atmosphere around the double screw extruder, over this extruder, and in the background. If we use this reclaimed rubber, it changes its properties, not only in the direction of being more reactive, but its internal viscosity changes, and some migration of additives is possible by producing of composite compounds, and for this reason reclaimed rubber should be investigated for the presence of some additives which are interacting later during new vulcanization in order to tune the properties and to estimate the right niveau of cross-linking in these new rubber compounds, which migrate during mixing at higher temperature and at higher shear forces. At investigation of the role of additives and microwave treatments, we did different experiments. which are already published, and these experiments proves us better properties due to introducing more elasticity to the rubber chains, and it allows us to break more easily sulfur linkages comparing to carbon-carbon linkages. And this process was investigated using temperature registration for different amount of plasticizing bitumen added to the ground tire rubber taken for devulcanization. And during all experiments, we compare the impact of plasticizer content, of torque, of screw speed, so all mechanical parameters on tensile properties of reclaimed GTR prepared by different methods using different plasticizer and also comparing with literature data, for example, for microbial desulfurization, excuse me, which is introduced by some scientists. It is, in my opinion, possible to find some microorganisms, but to do it on big technical scale, it's still very problematic. So near to the end, I have selected some publications. You can find all publications on this project and on this problem using the name of Krzysztof Formela, because he is a co-author of all of the works, like autothermal extrusion of ground tire rubber is the main problem which we investigate, as you can see, using different analysis and evaluating impact of heating conditions, of screw speed, of output on the possibilities of performing autothermal extrusion, aiming and sustainable development of this technology. So it's from previous year, from this year, some approach for using them in green composites. It is one of possible markets for reclaimed rubber, and in this case, not only low-road bitumen, but also organic peroxides were used as devulcanizing agents. Next one, using plasticizer soybean oil as green reactive plasticizer for SBR silica compounds. These articles are all available if you take the shown DOI numbers. And also microwave treatment with all advances and limitations, new article from previous year. And generally, as a modifier for thermoset polymers, which is connected with some modification of the surface of this waste tire rubber, not necessarily with the vulcanization. And the main thing is the combined impact of plasticizer and shear force on the efficiency of low temperature reclaiming and investigation of all influencing energetic treatment on short-term devulcanization of ground tire rubber. And we see that the temperature is more important factor. We have to optimize the temperature, but it is true for a given double screw extruder. In my opinion, the most important factor is the construction of extruder used for this process, which allows us to put shear forces in such a manner that the product will be not pulverized, but it will be stressed at condition of higher elasticity brought by temperature and additives, that the weakest bonds could be ruptured and could be broken. And so we can obtain our product with properties we need, and without good machinery it is not possible at applying low temperature for this degradation. So there's still possibility to work on screw configuration to achieve some better parameters regarding energy and effectiveness of the reclamations. So this project is still supported for this and next year from National Center for Research and Development. And these are the main scientists working on its projects. You have seen them at work, Dr. Krzysztof Fulmera and Łukasz Zedla. This time correct, the names are correct written. And so it is the end of the scientific part, and there was a need to present you some information about the situation of students from abroad which are at Polish universities. So I have invited my two PhD students from India, and they will share you, they will inform you about this. So maybe you go on. Please come here. Come on this side.
You can present that.
So I can say it, but you can show yourself. Marita is coming.
Oh, hi, hello.
So these were my Indian students, so you can see us, and they will answer some questions if there are some questions. So we have about 80,000 foreign students in Poland. Poland is not so big country. We have less than 40 million citizens from many countries of the world, but the most is from our neighbor countries like Ukrainian, Belarusian, and also there are some students from Asia. So the number of foreign students is increasing, but you have to know we are teaching in Polish, so my English is not the best. I'm not normally speaking everyday English, and there are not so many courses which are in English. So maybe popular is medicine, because medicine in Poland is on high level, and if the students pay for it, it is much less than in Western Europe countries like, for example, Germany, England, or France. And so the costs of for foreign students are much lower than in Western countries of European Union, but it is not so easy to obtain allowance or for studying in Poland. From India, we have 3,571 people. So it is during 1 year is almost 600 more, but I think a lot of them are studying medicine. We can see it in Gdańsk because our medical university has a special program for foreign students, also from Sweden, for example. We have here 6 public universities, the biggest are University of Gdańsk and our Gdańsk University of Technology. And into the main building, we are to the left. We are very good categorized between Polish universities. We have the highest rank in chemistry and as a whole university, and in Gdańsk University of Technology, we have about 16,000 students, and students from different nationalities, from 60 different nationalities, and between them we have 13 persons from India. And how many students altogether? I don't know. How many? 200 maybe. So to obtain scholarships in Poland is very difficult, I can say, because there are not programs which are existing all the time. It means sometimes they open a window, for example, at neighbor. Like last year, it was possible to apply for collaboration with India scientists, and it was closed in September. So this year we have possibility to apply for other countries. But if you observe Erasmus, NEVA, and have connection to some people which are already here, maybe if somebody is interested, could try to obtain some scholarships. We have some projects, but we have, I have to say, we have enough for our PhD students. So, and in Poland, PhD students still are interested in technical subjects. So in some other countries, there is a problem to find somebody for chemistry. We have not such problem, and that's why the programs are not too high paid, and it is much better to engage Polish PhD students because we can, for the same money, engage 5 Polish PhD students for 1 PhD student from abroad. So that's why scholarships for short visits are more available as for long-term visits, for long-term study. Tommy and Marina were lucky. They have a possibility to make the full program of PhD for 3 years here in Gdańsk with me. Here is the website of NEVA, where you can look for different programs for studying in Poland. And it's our main building, and it is view from my office where we are sitting now, but it was done 3 months ago. So thank you for your attention. If you have any question, we are ready. Thank you very much.
Thank you, Professor Haponiuk, sir, for wonderful and insightful talk, and especially the topic, recycling of rubber, which is very much important by considering the current scenario, all over the world, because right now the use of polymer or rubber is, enormous. So we have to also think about the how we can do the recycling. So in that term, in that case, your talk is really, very inspiring for all of us. It also contains lots of technique. How can we do that kind of recycling, and how we can apply, in which field we can use that kind of, rubber recycling technique to generate some other kind of products. And so I think this will help especially the students also to for further research, in this field. And so before going to, okay, I have, just few, curiosity about, as you already shown in your last few slides, that there is a lots of, PhD student at the moment, PhD, not only PhD and also undergraduate student at your institute, and not only at your institute, also in the Poland. So it is really, amazing to see those. In fact, I hope that in near future more students, and also some of our students from our institute also, they will get the inspiration to for further study or higher study. They can travel to your country. So I'm just wondering, that for those students, they need to, appear for some examination or something like that. What kind is the criteria of your institute? They have some special criteria. Unless, for example, they don't have the scholarship initially, but
No,
how they can approach? They can approach directly to the professor, and after that they have to communicate with the, program, graduate program school. of your institute, and at the meantime they also qualify, they also need to qualify for some exam?
So it depends. Usually it is an interview at all scholarships, but the main thing is you have some scientific background.
Right.
So you can show some papers, attendance to conferences, because you obtain points for everything. And with a good scientific background, it's possible to apply not only in Poland but all over the world. So it's you should use every chance to make publications and good journals to show you are well qualified young scientist, because then it's much more easier to find a place in scientific community.
Yeah, yeah, that's true. So I would also, like to mention few questions. There is what is appear. I mean, one of the attendees named Marcin Dawoski, he or she say they.
Marcin Dembowski from Singapore. He
I see, I
was,
see,
uh-huh.
I see. The question is that how much of the code remains in GTR and how does it impact the mechanical properties of the final product? Any significant porosity introduced this way? So can I read it again?
So mechanical property of the products, it was shown here in where we have here mechanical properties. Once and table 10, mechanical properties, and it is of raw compounds, not not vulcanized, so it means a thermoplastic. And after vulcanization, we have so about 5 megapascal, with elongation at break, in this example, about 200%. And the tensile strength obtained is between 4 and 8 megapascal, used alone. But the next possibility is to apply these obtained rubber compounds in a blend with different rubber, so the best of the same kind. For example, if it is SBR rubber, and so the best case is to use fresh SBR rubber and to replace some amount, for example, 1/3, then we can have better economy and acceptable mechanical properties. So it is my question, and
Yeah.
Marcin
Thank
can
you for the
write me a message.
And at the moment, just one more thing I would like to mention about our institute. Actually, due to some technical problem at the initial stage, I could not give the introduction about our institute also, because lots of attendees, I found that they are from various places of all over the India, as well as from other all over the world also. lots of students or attendees from the Poland, some are also from Singapore, as you mentioned. And I can also see two of your students who are sitting there, who are there. I mean, even can I get, may I know the names of the other students who are sitting beside you?
Yes, can you tell your names?
Tommy MJ, and she's Marina.
Yes. Hello. Hello. And I mean, possibly they also don't know much about our institute actually, because our institute is JIS Institute of Advanced Studies and Research. It's a very newborn institute. I mean, it started from its journey from last year, and it is situated in the eastern part of India, in Kolkata. And the institute is formed under the flagship of JIS Group, right? And at the moment, our institute have mainly three center of data science, center for health science and technology, and another department is center for interdisciplinary science. At the interdisciplinary science department, we are currently also working on polymer, and especially Dr. Prosenjit Saha, who is there, but I mean, due to some technical problem in the internet, he cannot, I mean, join with us through verbally. So I'm sorry for that, but he is working on in the polymer science. And our students, they are also, I mean, interested to work in this kind of, I mean, translational oriented research, I mean, which can be useful for further how can I say, development of our, I mean, environment in a sustainable way. And at the same time also we can solve lots of challenges or issue at the moment what our world is facing. I hope in that case it will be very much, I mean, helpful, your I mean, research as well as your today's talk. So I would like to thank all the attendees, and first, because I can see lots of attendees still there who are, I mean, joining with us. And a big thank you to Professor Haponiuk for present, I mean, your for your such a wonderful talk. And I have a special request, I mean, personal request to you on behalf of our institute, JIS Institute of Advanced Studies and Research. I mean, if it will be, I mean, great if you can sometimes over this corona pandemic, after this corona pandemic, maybe sometimes later you may visit our institute. In that case, we can have a, I mean,
Yeah, maybe for sure I will come to Kottayam maybe next year to
oh, that's
Professor
great.
Sabu
So
Thomas.
at the time, surely we will meet with you. So anyway, thank you very much for joining with us here today, and thank you for the
Thank
wonderful
you.
talk.
And if somebody knows, if somebody wants to have this presentation, so I can send it if I have an email.
Okay. Thank you, sir. I mean, possibly
So
the
you can distribute it, or I send it to you.
yeah. Okay. Then if the student attendees, anybody wants to take the presentation, they can get it. In fact,
I
our
will send it to you and you give it to everybody.
sure. In fact, the today's presentation was also live in our Facebook page of our institute, and we also have the recording. So possibly they also can get the, I mean, whole information. I mean, your thoroughly your talk. They can listen again, and at the same time, if somebody wants to get your presentation slide, they can also, I mean, request
Of course,
us.
yes.
They can get it. Okay. Thank you, sir.
Thank you very much.
Thank
Have
you.
a nice day and good health. Stay in good health. Stay healthy.
You too. Thank you, sir.
Thank you.